Hello there. We are going to take a look at this Worksheet A, Unit 5, Part 1, Model 1, just to make sure that you got everything that you're supposed to get so that you can go on to the exercises and complete them correctly. So, first off, we looked at these depictions of ionic compounds. We've got sodium chlorides, we've got the name up here, formula down here, and then a depiction of the structure of the ionic compound. So you'll notice there's this alternating pattern of positive, negative, positive, negative, positive, negative, and we see that also over here to the right, even though we don't have the same ratios. Again, we see this repeating structure of the positives and negatives, which is what ionic compounds have as a structure. Okay, so based on the examples above, the cation is always written first. So how do I know that? Well, sodium has a plus sign next to it, and sodium's written first here in the name, and it's written first in the formula. Calcium has a plus sign, again it's plus 2, but plus nonetheless, and that's the cation, and that's written first in the name, first in the formula. Same thing with aluminum, positive sign on the charge, or on the ion, and aluminum's written first in the name, written first in the formula. So that means the format for writing both names and formulas for ionic compounds is positive, where the cation always comes first, the anion or the negative one always comes second. Now, in terms of what happens to the name, we'll notice that the sodium ion, so any monatomic ion, meaning an ion made out of one type of atom, has the same exact name as the element. So if I look up Na in the periodic table, the name of Na is sodium. Look up calcium, Ca, the name is calcium, and that's the same. What's different, though, is the anion. So if I look at the name chloride, and I look up Cl in the periodic table, Cl in the periodic table is actually chlorine, and so notice this ending of chlorine has been changed to IDE. So we've taken off the INE and put on an IDE. This one's chlorine as well, but if we look at oxide, so oxygen is what O is, but again, when we're writing this as an ion, this is just for the monatomic anion. So monatomic meaning O is, there's just one type. We'll show you what a polyatomic is later on. We're changing the ending from, well, in this case, oxygen is the egen, and we're changing it to IDE. For the counting of the ions, so you're literally counting sodium, there's 1, 2, 3, there's 9 sodiums, there's 9 chlorides in this first picture. So we usually show ratios as reduced to the lowest whole number ratio, so that's a 1-to-1. If there's 9 of each, that's a 1-to-1 ratio. For calcium chloride, there's 5 calciums, 10 chlorides, so that's a 1-to-2 ratio. If it's reduced down, 5 to 10 reduces to 1-to-2. And then for aluminum oxide, there are 4 aluminums, there are 6 oxides, and therefore the ratio 4-to-6 reduces down to 2-to-3. And so you'll notice then that each of these ratios is the same as the subscript. So we'll notice that for the subscript of 1, we don't write 1. We've seen that before. But for the this is a 1-to-1 ratio, and for calcium chloride this is a 1-to-2 ratio, and for aluminum oxide 2-to-3 ratio. So the count, the ratio from the count in the picture, that is what we're using as our subscript, and it's the lowest whole number ratio, so it's reduced down. So you would not write Al4O6, it would be Al2O3. That's reduced down. Number 6, we already just did that. Okay, when we're writing the charges of the ions, it's important that you don't just write plus or minus, because, again, we need to indicate how many electrons have been gained or lost. So if something says just a plus sign, what that really means is +1. If something has minus, what that really means is -1. And notice if it's different, right, if there's more than 1 electron gained or lost, then we see the 2- or the 3+ or whatever. And it's just kind of the convention to put the minus sign or the plus sign after on the symbols. So you'll notice that if you write it the other way, I won't mind too much, but you'll notice it being written kind of backwards, 2-, 3+. And again, we don't write in the ones, but when we're asked for the charges, we should write that in down here. So sodium's +1, chloride's -1, calcium's +2, chloride's -1 again. Aluminum's +3, oxide's -2. And so what you should notice is that all of the charges add up to 0. So if I have, again, looking at the ratios, there's 1 of these for every 1 of these, that adds up to 0. If we look at this, well, you're given the math here. There's 2 calciums for, or sorry, there's 1 calcium, which is +2, for every 2 chlorides, which is -1. Well, if you do this math, that adds up to 0. Likewise for the aluminum oxide. So we have 2 aluminums, they're +3 each, so that adds up to +6. And then we've got 3 oxides, which are -2 each, so that all adds up to a net charge of 0. And then the pattern is, or the rule is, that the charge always must add up to 0. So that's how we're going to figure out what the subscripts will be. We're not going to see those pictures in the future. That was just a depiction to help us picture what's going on and how we're getting the subscripts. But the idea is that we figure out what the subscripts are by figuring out, well, how many of each ion do I need for the charges to all add up to 0. So that's very, very, very important. Typically, the subscripts, if we're going to have a subscript, it's not going to match the charge on the ion. And I'll show you what I mean in a minute. Now, in terms of this exercise you're supposed to do next, you can start on that on your own. What I wanted to point out is the table down at the bottom of this in the exercises section. There's nothing for you to do to that table. So when you look at it, you're not filling anything in. It's just giving you the charges of the ions. And you'll notice that that looks very similar to what we already talked about in the last unit with the periodic table regarding the charges that each column tends to form based on their valence electron count and the octet rule. But you're not filling anything in on that table, so when you go to do the exercises, you just use that as a reference so that you know the names of the ions and the charges that they have. Let's take a look, though, at just going over how to write formulas and name. And so, for example, if I want to do calcium fluoride, so you can look at the table at the bottom of this worksheet, but you'll notice that calcium is the cation, so it's written first. That's how I know that it's the positive. And fluoride is the anion, and I know that because it's written second. So, and we see that ending of fluorine changed to IDE. So I'm going to look up the charges for calcium and fluorine. So you know from their position in the table that calcium being from group 2 has a +2 charge. You're eventually going to have that memorized. For now, though, you can actually see that in the table on the bottom of worksheet A. So calcium's +2, fluoride, notice, is from the halogen column, column 17, so it forms a -1 charge, and so that's F-. And so there's the Ca 2+ and F-, again, based on column location, so we'll have those. You should know those already from the last unit. If you don't know those, you need to know them now. And so we're going to determine the number of each ion needed to make the charges add up to 0. So what I would first do is look at 1 calcium and 1 fluoride. So if I added up +2 and -1, let's see if I can get a little pen going here. So if I had 1 calcium, so that would be a +2, and 1 fluorine, which is a -1, and I add those two things together, those two charges together. So if that was a 1 calcium, 1 fluoride, that adds up to +1. So that doesn't add up to 0. So it's not a 1-to-1 ratio. There's not 1 calcium for 1 fluoride. So notice that, well, my overall charge is coming out too big if I had 1 of each. So notice that whatever I have the smaller charge on, I'm going to need more of that ion in order to cancel out with the bigger charge. So in this case, I'm going to need twice the number. So I don't want you to think about it as I need another -1. Think about it as how many times do I need to multiply that charge, and you'll see why I'm saying that when we go over ions that have higher charges and more difficult charges to spot. So I don't just need an extra -1, I need twice the charge. And so again, if I have 2 fluorides would mean that I've got 2 times the -1, and add that to the +2. That's very sloppy looking, but that would add up to 0. So I'm going to need to double the amount of fluorides, to cancel out with the 1 calcium. And so there we go. And so we write the formula. So that means I need 1 calcium and 2 fluorides. So CaF2 would be the formula for that. And notice I'm not writing the charges in. So I wrote the individual ions. So until you get the hang of this, I would write these out so that you have them in front of you to look at to do this figuring. But when it comes time to write the formula, notice we have subscripts. If there's just 1 of something, we don't put a subscript of 1. But there's subscripts, and there are no charges written up here anymore. Do not ever write any superscripts in a final compound formula, because when the positive and negative come together, those charges are effectively canceling each other out, and so the overall compound does not have a charge, and we don't write any charges in them, so that's another important rule. How about barium sulfide? So you look up barium and notice in the table, periodic table, it's in column 2, so that means it has a +2 charge. And you could also look at this in the exercise on worksheet A. Sulfide, so that's coming from the element sulfur. So notice the beginning of this looks like the element sulfur. The IDE ending means it's an S from the table. That's in group 6A, or column 16, and so that column has a -2 charge. And again, you can find that in the worksheet A table. And so you go ahead and write the formula for this. So first I would look at, what if I had one of these and one of these? Does that add up to 0? If the answer is yes, then that's your formula, just one of each. Start with the simplest case first. If the answer is no, then you need to figure out what the ratio is. And so usually, or always, the ion that we have the lower charge on, we're going to need more of. And so hopefully you figured out by now it should be just BAS. A couple other things, there's a shortcut method just to help you out if you're having trouble just spotting what the ratio should be. An example we have is, well, we actually saw this on our worksheet on the front side of Model A. But if you look at the charge on the cation and the charge on the anion, now that's not going to be the same as the subscript for that. So meaning, if I look at aluminum, its charge is +3. And again, I know that from the fact that it's in column 13 or 3A. Oxygen has a -2 charge. I know that because it's from column 16 or 6A. So notice this 3 is not going to become aluminum's subscript. And the 2 is not becoming oxygen subscript, but they're crisscrossing or they are swapping. Right? So notice I'm not putting the charges down here. So I'm not saying put a +3 down here, but I'm putting the numerical value of the aluminum charge. That is going to be the subscript for O. So it's crisscrossing, crossing over to the other element as the subscript. And the 2 from the 2- on the O is being put as the subscript for aluminum. So how this works, or why this works, is, again, if I have aluminum's got the higher charge, there's +3, I don't need as many of them, so I only need 2 of them to add up to and equal to and cancel out with the charge of the oxygen. So again, I need a little bit more, like I just said in the last slide, I need more of the lower charge. So -2 is a lower magnitude charge than +3, so that's why I'm going to need more of the one with the lower charge. So that's why the crisscrossing method works. And so notice this would add up to 0. We saw this on worksheet A anyway. Same thing with this. So notice I'm taking the 2 from the calcium's +2, and that's becoming the subscript on P. And for P, the subscript, or the charge is becoming the subscript on calcium. So I need 3 of these +2 charges to cancel out with 2 of the -3 charges. And this works for anything, actually. So even if you think about, the example of, NaCl, Na is a +1, Cl is -1. Well, technically you're crisscrossing, right? And that's a 1 and a 1, and so that's why we would write it as NaCl. Right. The only thing we have to watch out for is, like we saw the barium sulfide on the last slide. So Ba2+ and S2-. If you crisscross, what you end up with is Ba2, S2. And the problem with that is that if there's a factor in common with the subscripts, we really need, for ionic compounds to be written correctly, we need to have the lowest whole number ratio. So this would be reduced down to the BAS that we saw reported on the previous slide, because I only need one of each technically for the charges to cancel out and add up to 0. So in class we will do a lot more practice. You are to finish the rest of exercises on worksheet A as best you can, following the rules that we just talked about.